Hello everyone, welcome to Gchem classes. So today we are going to see gaseous state, correct? Okay, we'll see the important points based on gaseous state, and then the concepts we'll see. Based on those points we'll see the concepts and whether those concepts is applicable to our PYQs or not, that also we will see it. And then you just remember one thing, whatever concept you are going to learn now, this will be beneficial for your upcoming examination. So try to solve based on this. And again I am saying that don't try to solve new questions and don't try to, whatever you have not studied till now, don't touch that one, okay? So whatever you have studied, well studied, that only you do revise, okay? Because it is asking from entire syllabus, correct? So whatever you know, first concentrate on that particular topic, that particular point, that particular concept, okay? Leave the new one, okay? Because now if you are touching the new one, then your old one will be also you won't be able to answer from the old concepts also, okay? So whatever you know already, from there itself you do practice, correct? And likewise, after your JAM examination on this 12th February you have examination. After that, immediately from 13th February we are starting a new batch, okay? From 13th February we are starting a new batch. So if you want, you can enroll it, okay? You enroll it, you will get benefited for, like, the lectures will be available, okay? In detail lectures will be there, and then maximum question we will solve it. Because see, concept you will get it from anywhere else, okay? But you have to solve based on those concepts. You have to solve maximum number of questions, then only that logic you can play it, right? So you know the formula, correct? But how to apply that formula, that you have to learn it. And for that, no one can teach you how to apply those formula, right? Including me also. I also can't teach you how to apply those formula. What you have to do, you have to practice number of problems. So that problems we are providing, we together will solve in board, okay? So like it will give you the questions, I'll also solve, you will also solve. It will be two-way interaction, okay? Like directly in live you can ask me question and I'll reply you, correct? So likewise we will have live classes, and then whatever you are going to learn in entire week, you will have one weekly to see the whether you are able to solve those questions or not, okay? Whatever you have learned in entire week, correct? So now just we will focus on this 2023 IIT JAM 2023. So remember, from 13th February we are starting a new batch for IIT JAM 2024, correct? So now first we'll see in the gaseous state, we'll see kinetic theory of gases, okay? That equation we'll see it, that is PV equal to 1/3 mn c square, okay? So right, so whenever it will say for ideal gas, this will come in the picture, okay? And one more equation is there for ideal gas equation, that is PV equal to nRT. So this is for ideal gas equation, this is for kinetic theory of gases, okay? So these two equations are there, and then by using these two equations, you are getting one new equation that we call van der Waals equation, okay? That is equation of state, that we call equation of state. So there some modification will be there. So first we'll see what is m here. This is mass of a molecule. What is n? Number of molecule. What is c square? This is RMS, directly root mean square, okay? Root mean square speed, we can say it. So these values they will give, and then they can ask from kinetic theory of gases, okay? Solve this problem, okay? Whether whatever they want you can write it. But in this place here, Boyles Law, Charles Law, Avogadro's Law, Gay-Lussac's Law, so everything is mixed up, like all the laws we have applied, and then this equation we got it, right? So if you see one by one equation, you will get to know. So directly we can relate this one, P1 V1, okay, but R and then T1. We can remove this R because this is a constant term, equal to P2 V2 but T2. We can see, we can say this one, because n we will say for 1 mole, okay? If we are taking 1 mole of ideal gas, this is for ideal gas equation, right? So 1 mole of ideal gas, then this equation you will result it, and then with this you can solve it your problem, right? P1 B1 equal to beta T1 equal to P2 B2 T2. So by applying this equation, okay. So now these are the basic things, okay. Like now we will move towards the advanced, okay, where the questions, maximum questions can arrive, okay. Sometimes they are asking directly for ideal gas equation, but how they will modify here? They will say that for 3 mole of ideal gas, what will be the equation? Then your equation will be play smartly, okay. So it will be 3 RT, correct? If they are saying for 3 mole of ideal gas, then it will be PV equal to 3 RT, or maybe if it is a multi-selection question, option A will be this, option B will be your PV equal to 3 RT, sorry, P equal to 3 RT but a V. Likewise, they will just modify it. So you have to play with the equations, correct? Whether they are asking for 10 mole, whether they are asking for 1 mole, whether they are asking for 5 mole. So likewise, this will be modified. So here n equal to, we have 3. We have taken 3, right? So don't get confused with your most probable velocity, okay? So this is like the condition you have to see in question what they are asking. Based on that you have to solve this, right? So PV equal to n. In place of n we have put 3, right? In place of n we have applied this 3, right? So now we'll move to the next topic. We'll see the different type of graphs, okay? Because graphical question also they may ask you, right? The plot, like which graph will be for Boyles law, which graph will be for Charles law. So first we'll see the Boyles law. Here V is proportional to 1/P at constant temperature, okay, at constant temperature. So directly we can write V1 P1 equal to V2 so directly we can write it V1 P1 equal to V2 P2, okay. With this we can solve it at constant temperature. It should be mentioned that at constant temperature, then only this will work it out, okay. So we'll see the different type of graph. This is volume and this is pressure. If volume and pressure, if you are seeing, so if volume is increasing, okay, your pressure will be lesser. If pressure is increasing, your volume will be decreasing, like this. So this will be normal. This like V is proportional to, like V is inversely proportional to pressure, okay. This graph you will get it. This will be volume versus 1/pressure. So this will be like this, correct? So how it is, see, if volume is getting increased, your 1/P is also getting increased, okay. So 1/P is getting increased when volume, because volume is inversely proportional to P, pressure, right? But 1/P it is directly proportional, we can say it, right? So as volume is increasing, 1/P is also getting increased. So this I will make little bit smaller. So one more graph I can make it here. I'll just remove this constant temperature, okay. So one more graph I'll make it. So it will be log V and log pressure. This side log pressure, this side log volume. So how it will be? It will be like this, okay. Directly we can say if you are increasing your log V, your log P will be getting decreased, or if you are increasing your log P, your log V will be getting decreased. So this 3 type of graph, 4, 1, 2, 3, 4, 4 type of graphs are there that you should know in well manner, okay. So whatever now I am giving for physical chemistry or inorganic chemistry, do one thing. You make a, like yesterday also I told you, you make a page and you just write it down those points, okay, and those page only you do revise, okay, 2-3 times in a day. So what will happen? At least you will remember something till Sunday, right? Because your examination is on Sunday. So these are the graphs. So next we'll see for Charles law, okay. Next we'll see for Charles law. How the graphs is looking for Charles law, we'll see it. Okay, generally they will ask only for Boyles law, Charles law and that gas law, okay. Okay, for Charles law, volume is directly proportional to temperature at constant pressure, okay. When the pressure is constant, the volume will be directly proportional to temperature. So here we can write V1 T1 equal to V2 T2. So this is very much important when they'll ask for 2 different gas or 2 different volume or two different temperature, they will ask you to compare. So how the graph will looks like? This is the volume, volume versus temperature. So as your volume is getting increased, your temperature will also get increased, or you can say as you are increasing your temperature, your volume will also get increased at constant pressure, correct? So this is the graph for Charles' law. Next we'll see Avogadro's law. Okay. Volume is directly proportional to your number of molecule or moles, you can say it, at constant pressure and temperature. Finally, from Charles' law, Boyles' law, Avogadro's law, what you are getting? PV equal to nRT. Okay, this equation finally you are getting for an ideal gas. Okay, this is not for real gas, this is for ideal gas. This you can modify it because many times they will ask PV equal to N. N is moles, right? Moles how? The given weight divided by molecular weight RT. Okay, just modify it. PV equal to this volume. Okay, 1 second. What we will do it, just this volume we will take it that side. So P equal to this given mass divided by volume, okay, and then RT by a molecular weight. So given weight mass per centimeter cube or gram per centimeter cube is your density, correct? So directly we can write it, it's a density term divided by molecular weight and then RT. Okay, so pressure is directly related to your density term divided by molecular weight and then RT. Okay, if density is also given, then also directly you can get your molecular weight. Okay, or if they given molecular weight, you can directly calculate the density. If density and molecular weight both they have given and temperature, you can directly calculate the pressure. Okay, for that particular container, how much pressure it is developing, that you can calculate. Very important thing we'll see. It is a very much easy, but it is very much important, that Gram's law of diffusion. Okay, if you see, they have asked many a times. I think this time also I am just looking one questions for Gram's law of diffusion. Okay, whether they will give for nitrogen and oxygen, whether they will give in relation between hydrogen and oxygen, which one will be move faster. Okay, that will be based on Gram's law of diffusion. Gram's law of diffusion of gas. Okay, so rate will directly write, rate of diffusion is directly proportional to 1 by a rate of diffusion is directly proportional to 1 by a under root d. Okay, and directly you can just relate this. Directly you can just relate this one. What is R? R is volume of gas divided by time taken. Correct. So that you can put this side. So we are just making some formulas where directly you can apply to your examination. So we can say R1 divided by R2 equal to your, it will be your, suppose it is inversely proportional. So D2 will go up divided by D1, and this directly you can relate it with molecular weight 2 divided by molecular weight 1. This relation you can give directly with this rate of diffusion to your molecular weight. So directly you can say, if it is molecular weight, directly you can say weight 1, okay, given weight, okay, given weight 1 divided by given weight 2 equal to under root your M2 molecular weight 2 divided by molecular weight 1. That also you can do it because this is a density, so volume term will get cancelled. So whatever the weight is there, based on that you can just see M2 by M1. Okay, so this is one equation you are getting. This one is another equation you are getting. So whatever questions we will practice it, in that time you will see how we are just solving based on this equation, how we are solving those diffusion problems. Okay, so next we will see it. So we'll see equation of state. Okay, that is van der Waals equation. So equation of state, and to reach this one we should know before that like compressibility factor. What is that compressibility factor? We'll see. After that we'll reach this equation of state. Okay, compressibility factor, which we denote with Z. How you are going to write? PV equal to Z and R T, or Z equal to, you can write it PV divided by nRT, and N already we know that it is weight divided by molecular weight, and this volume we can say that volume of a gas. So what will be there? Volume factor is there here, weight divided by molecular weight. So directly it will get changed. We can say it Z equal to PV, this N we are opening, okay. So it will be, let me open this N, it will be W divided by M. So M will go up, so M, and then here it is RT. So this also you can write it, and the condition you should know, if Z equal to 1, then we call it, it's a ideal gas, okay. It will behave like a ideal gas. If Z is greater than 1, then it will be having positive deviation, okay, positive deviation. If Z is lesser than 1, then it will be negative deviation. So now we'll see the volume correction, because slowly we are moving towards equation of state, correct? So now we'll see the volume correction. First we'll see for volume correction. Okay, volume correction that will be representing by B, okay, the small letter B. Vector volume, your VI equal to V minus NB. And what about pressure correction? Pressure correction, okay, that will represent by A, okay. So it will be like PI equal to your P plus A bate V square, and that is for 1 mole. Here also we have taken N, so what we'll do, here also we'll take that this will be N square bate V square, okay. So if we are taking 1 mole, this N factor will also vanish. Here also from this also this N factor will go up, right? But we are if it is for N mole, then this N will also retain, this N will also be retained here, right? So this will be pressure factor, correction factor, this is volume correction factor. Now put this thing in your ideal gas equation, so it will convert it to the real gas equation. So it will be P plus A N square divided by V square, and then your V term will be V minus NB, that will be equal to nRT. So whatever equation you got, this is called, we called it equation of state or van der Waals equation of gas. Just write it down. Unit of A, okay, it will be Pascal, okay, and then meter 6, that they will ask no unit for your A and B, the term volume factor, then your pressure factor, meter 6, and then mole inverse 2. Or we can write it this one in this way, that Newton meter for mole inverse, okay. Or we can write it unit here, it will be like your joule meter cube mole, okay, inverse 2. So joule meter cube mole inverse 2, this is one, this one, and this one. So 3 unit we can convert it. So multi-selection question they may ask you. What about B? B will have only one, it will be like M3 per mole, okay, meter cube per mole. Okay, next we'll see Boyles temperature, okay. Sometimes they might ask what is the Boyles temperature. So this Boyles temperature, the TB, this is nothing but a temperature where the real gas is behaving like an ideal gas, okay. The temperature where the real gas is behaving like an ideal gas, we called its Boyle temperature. So TB equal to A bate B and then R, okay. So this A is your pressure factor and B is your volume factor, okay. So these two you just you solve this one with your gas constant, so you will get your TB, correct. That is your Boyle's temperature where the real gas is behaving like an ideal gas. And we'll see for critical constants, okay. This gaseous state is very much interesting if you see lecture by lecture, okay. Maybe it will take more than 20 lectures, but it is very much interesting because one by one everything we are solving and then we are getting, whether it's a Boyle temperature, it is nice relation is there, okay. So whether it's a critical temperature, critical pressure, critical volume, okay. So just we'll see the critical terms. First we'll see for TC, okay. This is critical temperature, it will be 8A bate 27 RB. we'll see for PC critical pressure A bate 27B square. Okay, then we'll see for VC critical volume, it is 3B. Okay, then in term of A volume factor and your pressure factor, okay, we'll see how the changes is happening. So suppose we are just calculating A in terms of critical temperature, pressure and critical volume. Okay, what will be the equation? It will be 27, okay, R square TC square divided by 64 PC. So here critical temperature, critical pressure, okay, for A, because this is a factor, this is a pressure correction factor, correct? Now for B, what we will get it? This is R TC but a 8 PC. Okay, so this constant term you should practice, okay, because directly they will ask this term and they will say that what will be your critical pressure, critical temperature, critical volume. We'll solve the problem, that time you will see, okay, how we are solving this by taking this formula, how we are solving the question. Next we'll see Maxwell distribution. Okay, Maxwell-Boltzmann distribution. Okay, so this graph is very much important, if you could see. Okay, then second will be there your this one. Okay, this is for temperature T1. These are isothermic. Okay, this is your temperature T2, correct? This is fraction of molecule. Okay, and this way it's a velocity. I'll just write velocity or speed, okay, whether it's RMS, most probable velocity, whatever is there. So suppose this place you see, when T1, your velocity is reaching here where the maximum number of population is passing through this velocity in temperature T1. So this will be your M velocity, MP, most probable velocity we could say it. Suppose if you are increasing temperature, so see the population is shifting towards the most probable velocity is now shifting towards higher velocity side. Okay, suppose this is 500 meter per second. Okay, 500 meter per second velocity. It will be your 700 meter per second if you are raising the temperature. So here we can say that temperature T2 is greater than temperature T1, correct? So with this only you just you will be solving that RMS velocity, your most probable velocity and your average velocity. Okay, these three relation always they used to ask. Okay, so directly you can say this velocity, whatever velocity mean, whether it's a RMS or root mean square, or root mean square, most probable or average velocity, this will be proportional to your temperature with molecular mass. Okay, so as mass is getting increased, whether it's a root mean square velocity, most probable velocity or average velocity, that will get decreased. If your temperature is increasing, all the three will get increased. Okay, so one by one we will see those formula, and then with the two gas we will just relate it, with the two temperature we can relate it. Okay, generally they will ask for oxygen and hydrogen, they will ask for oxygen and nitrogen. Okay, and then say that what will be the root mean square ratio, they will ask you to find out the ratio. Okay, so first we'll see most probable velocity 2 RT bate M. What we will do it directly, we will just like write the ratio also. Okay, together we'll write everything in one place. Okay, this will be for most probable velocity, this will be for is2. Okay, directly we'll write in one place only. This is most probable velocity, this will be your average velocity, and then is2 your RMS. Okay, root mean square velocity. So here we'll write it 2 RT bate M. Okay, is2 8 RT bate pi M, is2 3 RT bate M. So if you are solving here, what you will get it, just RT and M is getting cancelled for same mass. So it will be root 2 is2, here it will be 8 bate pi, root 8 bate pi, here it will be root 3, right? Suppose you are solving, this is 1.14 and that value if you are dividing, so you take it 1 and then is to 1.28 is to 1.224. Okay, so these are the formula: most probable velocity, average velocity, root mean square velocity. These are the ratio. Okay, but these three we are finding the ratio. Suppose they are asking for gas molecules, that will solve it in problems. Okay, directly you can see it. If gas molecule they are changing, whether it's whether it's a most probable or average or RMS. See, this R is constant and this number is constant. See, temperature and your molecular weight. Everywhere temperature and molecular weight is in the same fashion. Okay, so that's why directly with this equation you can solve it, your Boltzmann distribution, Boltzmann-Maxwell distribution. Okay, so one more formula is there which is very much important for this Maxwell-Boltzmann equation in terms of your quantum. Okay, so function of this speed. Okay, how it will form? So equal to function of this speed, okay, the velocity or speed, whatever you say in this x coordinate, it will be 4 pi and m bate 2 pi rt. This will be 3 by 2 and then v square exponential factor e minus mv square divided by 2rt. So this is very much important formula. In your previous year question, directly this formula they have asked. Okay, but what modification they did in this problem? They say that this function, whatever the volume like velocity function, that they have converted to they have taken as 1. Okay, so if they have taken this one as 1, so whatever the remaining is, so this you can say it's a okay, and then exponential factor m v square divided by 2rt. This formula is directly placed in your option. Okay, so just read it, that question 2 or 3 times, you will get it your answer. Okay, get it done your answer. Correct. We'll directly take up the questions. Correct. So directly we will take up the questions. So first question is from 2022, question number 27. Okay, I just deleted this one. That's the same formula they have asked in this question. So it is like question number 27. Okay, from the year 2022, the Maxwell-Boltzmann distribution. Okay, they have given, even they have given in the x direction. Okay, one dimensional box. So Vx, velocity is Vx at temperature T. Okay, temperature T they have given. A is a normalized constant such as, so A they have just given, this A is normalized constant and this is infinity. So it is minus infinity to plus infinity, and then function of this Vx, dVx equal to 1 they say. Okay, they say it's a 1. Okay, and Kb is the Boltzmann constant. So here they have taken Kb. Okay, this one. Okay, so which relation will be your correct relation? So see, the first term, whatever we have written this side, if you are taking that as a, okay, this for this I'm talking about this one, Vx equal to, if you are taking this one as a, and then your exponential factor is there minus mv square divided by, you were having 2rt, correct? So you just see whether this formula is here or not. Okay, and here you have taken Vx, so you just write it here Vx. Okay, okay, option A will be your correct answer. Okay, instead of R they have given Kb. Just we can modify it. Okay, because there is only the factor of your Avogadro's number. Okay, based like Avogadro number, if you are multiplying you will get it, that one, right? So it will be like your option A. That directly I'll just write exponential factor m Vx square divided by 2 Kb and then it is T, right? So this one, option A will be your correct answer. It is a direct formula based question, right? Next question is question number 56. Okay, question number 56. Let's see. At constant volume, okay, I just rub this one. Question number 56. Try to solve yourself also. Okay. At constant volume, okay, volume is constant just write it down, whatever factor they have given. Heat they have given 1 kilojoule, okay, 1 kilojoule they have given, just convert it to the 1000 joule, okay, is transferred to 2 moles of an ideal gas, so N equal to 2, ideal gas at 1 atmospheric pressure they have given 1, and 298 Kelvin, so temperature T1 298 Kelvin. The final temperature of the ideal gas is, so T2 they want, okay, final temperature of the ideal gas is, so T2 they want, right? We know that Q equal to delta energy, and that is equal to NCV and then delta T. So this delta T we can write it like T2 minus T1, because we don't have delta T, we have T2, because we have to calculate T2, so T2 minus T1, we have T1, right? So now first we have to calculate this CV, and then we have to put it here, because N we have already, Q we have, okay, so just CV we will calculate it. I'll just calculate here. So what is CV? It is 3/2 R. So whether R value they have given, yes, they have given 8.3, okay, so it is 3/2 into 8.3, so how much it will come? It will be something, I have calculated, it will be 12.471, 12.471, okay, this much it is coming, that value you put it here. So you have Q value also, right? So it is 1000 equal to N you have 2, and then CV you have already got 12.471, and then you have T2 minus T1, T1 is 298 Kelvin. So what you have to do it, you just keep this one in this place, 298 Kelvin, remaining you just send it this side, so 1000 divided by 2 into 12.471, right? So how much it will come? T2 equal to this minus, if that is going that side it will be plus, so I'll just say whether I have solved this one, okay, okay, let me first write it down and then I'll write the values, 12.471 and then plus it will be 298. So how much we are getting? Yes, I have solved, it is 338.09. Okay, you also try to solve, you will get this value only, 338.09, and this is your answer, right? It is falling better, like it is best falling between the range they have given, and they want round up to the 1 decimal place, right? 1 decimal place means it will be, your value will be 338.1 Kelvin. Okay, this will be your T2 temperature, correct? So the next question, whether we have from the same year or no, we don't have, okay, directly we'll go to 2021. Okay, in 2021, the question number 27, right? See, direct formula they have asked. This I am not solving in board. You just see the volume correction factor for a non-ideal gas in terms of a critical pressure. In terms of a critical pressure, critical volume and critical temperature and gas constant R is. Okay, so you just see the correction factor of it, volume correction factor they are asking. It means they are asking for B. So B equal to, we know that it's a RTC divided by 8PC. The first option, option A, will be your correct answer, correct? So directly formula they have asked in this. So next question, question number 50. Okay, question number 50. In physical chemistry, this is very much easy, right? Sometimes they will ask calculation, sometimes directly they will ask the values. So question number 50. Okay, this we can solve it, because this is, we have to solve it, otherwise we will not get answer. Okay, so let me solve this question number 50. If the root mean square speed of hydrogen gas at a particular temperature is 1900 meter per second, so they have given RMS for hydrogen gas, how much it is? 1900 meter per second. Okay, and then what they have given, the root mean square speed of nitrogen gas at the same temperature. Okay, temperature is constant, correct? Temperature is not changing, so RMS of nitrogen at the same temperature, okay, that we have to calculate it in meter per second, right? You can write H2 and N2 also, there is no problem, because if you are dividing it will get cancelled out. Okay, so now what you have to do it, because you already know that any volume factor is any volume, like directly I'll write RMS. So it will be directly proportional to your temperature divided by mass, under root temperature divided by mass. Correct. Temperature factor is your constant. So again we can write it RMS is directly inversely proportional to your 1/, that molar mass. Correct. So now for hydrogen you just write it out. If it is suppose for hydrogen, what will happen? Here the hydrogen will come. If you are writing for RMS for nitrogen, it will be like 1/m, and then here it will be nitrogen. So just what they want, the RMS of N2, right? So just divide it. Okay, you have to do this one, right? VRMS H2 divided by VRMS N2. Let's see how much it is coming, equal to under root, it will be just reverse, MN2 will be top and then MH2 will be in down. So how much is this? N2, it will be like 28 divided by 2. So how much it is coming? 14. Okay. They have given this value, right? So this value we have to put it. So okay, so 1900 divided by RMS N2 equal to your, how much you are getting? 14, under root 14 you are getting, right? So this is cross multiply. So VRMS N2 equal to your 1900 divided by, this will come down. Okay, this will go up. So under root 14, whether we have calculated? Okay, 3.74. 3.74, and then final value will be something around 508.02 meter per second. So this much we are getting. Okay, 508.02 meter per second, and your range is 507 to 510. So very much it is falling under the your given range. Correct. So now next will be the next question we'll take up. Next question is from 2020. Okay, next question is from 2020, question number 14. Okay, graph they have asked. So graphical question is very much interesting, right? So graphical questions we like very much, because the relation we have to find it, right? Question number 14, the Boyles temperature. Okay, Boyles temperature they have asked. Boyles temperature we already know, and that they have given definition also. Okay, defined as the temperature at which the properties of a real gas coincide with those of an ideal gas in a low pressure limit. Okay, they are just writing low pressure limit. The graph that shows the pressure dependence of the compressibility factor for a real gas at TB. So Z equal to 1, it never be lesser than or equal to greater than. Okay, so just you have to find this type of graph. Suppose this is your Z value, compressibility factor, and it is 1. Okay, whether it's starting from 0 and it is reaching upper limit. So if it is Z equal to 1, so your ideal gas, like your real gas, like it is a pressure factor. So it will be like this, right? It will directly go. Okay, and then after that, if you are increasing pressure, the compressibility factor will be increasing. Okay, so first option won't be, because it is going lesser than 0 and it is directly going down, right? It is like this won't be. Second one, okay, second one can be possible. Okay, option B can be possible. Let's see another options also. Option C can't be possible. Okay, option C, this can't be possible. Again lower and then it is going upper, it won't be. And then option D is also not possible. See, option D is directly it is increasing with the pressure. It won't be, right? For some time it will hold up. Okay, if you are increasing pressure slowly, sometime it will hold up and then it will increase. Correct? So this option B will be your correct option for this particular question. Question number 14. Correct? Next question is question number 54 from the same year. Question number 54 is very nice question. Okay, graphical question again. So I like very much graphical question. Okay, even I guess you also like the graphical questions more, right? So question number 54, answer itself is given in your graph. This is a fraction distribution function. Here it is a speed. Okay, here distribution factor, and what they have given, I'm just like this they have given, and this peak only I'll write. Here it is written 500. So 500 means 500 meter per second, and this velocity we know that it is most probable velocity. So the Maxwell distribution of speed of a gas at temperature they have given 300 Kelvin, correct, is given below. The molar mass of this gas, molar mass they want. So M value they want. What will be the M value? Okay, in to 1 decimal place only they want. R value they have given. Okay, it is 8.3. So it is nothing but just you have to calculate. They want Maxwell distribution curve, the molar mass. Okay, they are not asking RMS or most probable velocity. From most probable velocity also you can calculate it. So what is the formula for most probable velocity? M under root 2 RT bate M. This M we want, right? This value already has given. So just we'll do the cross multiply. Before that I'll just do what? I'll just square it. Okay, so I'll to remove this under root. So just do it. This is square equal to 2. This is 2 RT bate M. Now just write it down. That cross multiply whatever we were doing. So it will be M equal to, it will be 2 RT divided by C V square most probable. Okay, so 2 into 8.31 they have given, or 8.3 they have given, 8.3 they have given. So don't write 31 because whatever they have given just take that much only. Temperature it is 300 Kelvin and divided by your RMS is 500. So 500 into 500. Now you have to solve it. Whatever you are getting, that will be your molecular mass. Whatever value you are getting, that will be kg per mole you will get. That you have to convert it to the gram per mole, right? So how much we are getting for kg per mole? We'll see it. It's a 0.01992. Okay, that you have to convert it to the gram, right? So how much it will come? 1, 2, 3. So it will be like 1, 2, 3. How much it is coming? 19.9. So how much integer they are asking? Round up to 1 decimal place. Okay, 19.9. So this much gram per mole you are getting. Okay, this much gram per mole you are getting. So this will be your answer because the given range is 19.8 to 20.2. So you are getting your answer, right? Question number 54 we have solved. Then next question, whether we have? No, we don't have. 2019 we will take up the question. 2019 question number 14. Okay, according to the kinetic theory of gases, the ratio of root mean square velocity of molecular oxygen and molecular hydrogen. Okay, just see, second question we got it from this ratio kind of thing. Okay, this ratio, so no need to, so if you don't know the RMS velocity formula, then also you can solve it. I'll show you how. If you don't know the RMS velocity formula, then also you can solve it. So question number 14, according to kinetic theory of gases, the ratio of the root mean square velocity of molecular oxygen and hydrogen, right? So just write mean, you just write. If you don't know that mean, we know that this we know already, under root T bate M. This much if you know, this ratio type of problem will get solved. Okay, and particularly if they are asking for RMS velocity or most probable velocity, then you should know the formula. Otherwise, if ratio kind of thing they are asking, with this formula only you can solve it. See, with this formula only I'll solve it. So now the ratio they are asking, temperature, it is like at constant temperature or what? Yeah, temperature is 300. So 300 Kelvin means it's a constant temperature only because they are not changing the temperature factor. So now we they want velocity of molecular oxygen and molecular hydrogen. So this will be for mean for oxygen divided by mean for your hydrogen. Okay, so now equal to your temperature factor I am just removing. So here it will be MH2 divided by MO2. Okay, so now just we'll see MH2 is 2 divided by your MO2 will be 32. So 232, it will be 16. So it will be 1 divided by 16. So it will be 1, 4. So your answer will be, just we will write it. It will be 1:4. We'll see 1:4. Option C. So option C will be your correct answer. Okay, see, we have not written any formula here for RMS velocity. Okay, if ratio kind of thing is there, everything will get cancelled out only whatever they want, because temperature it is a not constant factor. That's why what they have done in question itself, they are saying that temperature is 300 Kelvin for both, right? So it means temperature also it is constant. So now easily you can solve it. So next question we'll take it up. It's question number 32. Question number 32. Okay, the unit, see again they are asking the unit of the constant A in van der Waals equation of a state of a real gas and can be expressed. So it is a pressure factor, right? So with pressure factor we already saw in our here only I'll solve it. So question number 32 they are asking only unit. For this A we know that option A it will be having, because we have Pascal, meter, like meter 6 and then mole second inverse. Okay, this we have, but they have just arranged that meter in first and then Pascal second they have put. This will be your one formula. Then meter Q and Pascal it won't be together like per mole per square. So option A. Okay, one is option A, and again option B won't be there because meter 6 joule. If you are taking joule, it will be like if you are taking in joule factor. So joule, meter Q, and then mole second inverse. Okay, so option A and option D. So option A and option D your correct answer here, right? So question number 32 also done. Now next is question number 52. Question number 52. 1 mole of an ideal gas is subjected to an isothermal increase in pressure from, okay, this we have to solve it. Okay, they have related directly from Gibbs free energy. Okay, so this type of question it is very much difficult whether it's from gaseous state or it is from your thermodynamics. Okay, so question number 52. Okay, 1 mole of an ideal gas, 1 mole means N equal to they are giving 1. Okay, subjected to an isothermal increase in pressure, temperature is constant. Okay, increase in pressure from, okay, P1 they are giving 100 kilopascal, so 100 into 10 to the power 3 Pascal, and then 2000 kilopascal, so P2 equal to 1000 into 10 to the power 3 Pascal. Okay, temperature constant means they have given 300 Kelvin. Okay, the change in Gibbs free energy of the system, so delta G they want, system is in kilojoule per mole they want. Okay, kilojoule, whatever the joule per mole it will come, you have to convert it to the kilojoule per mole. So delta G formula is minus 2.303 then N R T log you have P1 but a P2. Okay, so now just we have to solve it. 2.303 into N is 1 into R 8.3 into temperature is 300 Kelvin, and log it will be your 100 divided by 1000, so it will be 1 by 10. So we just solve it. 2.303 into 1 into 8.3 into 300 into log 0.1 will be minus 1. Okay, so minus and minus it will become plus, and this value how much it is coming, I've just calculated 5734.47 joule per mole. Yes, so that we have to convert it to kilojoule because your unit it has given kilojoule per mole in answer, right? So it will be 5.7 and decimal any one decimal place, so 5.7 kilojoule per mole. Okay, so this is your answer. Okay, try to solve and write down all the formula in one place. Okay, and do practice. Okay, do practice those formulas, because directly formula in physical chemistry you will see 1 or 2 questions they will ask from directly your formula based, correct? So I think you just try to solve those questions. Okay, time is not there much, so whatever you have studied, do revise well. Okay, now don't waste time here and there. Okay, just concentrate in your work, in your table, and do practice. That's only it is required for you, right? So thank you very much.